A few words about AlphaSense. Then we also will have a few words about CNCF community itself. Then the main reason why we're here today, we have three wonderful talks. One from Oscar from AlphaSense to tell us a journey in our cloud platform engineering. And then Yury from Upbound and Jan from Cloud Prism will tell about their journey with the Crossplane. And Huy Mai from Ericsson will tell us about middle free provisioning with the Kamaji hosted control planes. So definitely very exciting agenda. A lot of control planes for today. Just looking forward. So, yeah, as promised, about AlphaSense. Before we start, can I ask to raise a hand if you haven't heard about AlphaSense before? All right, that's still quite good, yeah. So there are definitely very many familiar faces in the auditorium, but for those who haven't heard before, let me just try to fix it for you. It is very, very hard to describe the company and the technology just in a few minutes when you work there for 8 years, but we'll try. We'll have a few minutes for that. So that's AlphaSense simplified. That's pretty much what we do. We aggregate and also create all the different premium content, pretty much like Netflix aggregate, like Netflix creates its own content. And then we help all the businesses in the world to make decisions much faster. Basically, to make decisions in minutes, while we help them to provide all the insights in a second. So it looks quite simple, right? In reality, it is less simple. We have a superb technology and also very great interfaces built in one cohesive product. And this is pretty much how it is viewed by our customers. And we're doing quite great as a business. And why we think so, I hope this slide pretty much speaks for itself. We have more than 4,000 customers across each and every industry who pretty much, you can recognize all these brands, I guess yourself. And all of them are AlphaSense customers. Speaking about technologies, mostly latest and greatest, cloud native stack, Oscar will tell us more about that part. Kubernetes, multi-cloud, Crossplane, Terraform, all the cloud native stuff you can imagine. And also we train our own LLMs, by the way, definitely worth mentioning. A lot of GPU stuff. We have 400 engineers globally, and what makes our teams quite unique is definitely a focus on a high talent density. This probably is one of the key focus areas we have, especially during the last several years. Speaking about our values, AlphaSense was born in Finland, so you probably recognize the word CISO. Yeah, if you of course like watched recently the movie, that's not the way how AlphaSense like inside. So for those who watched, please don't think that we are something like that. It is much more about resiliency and about the kind of quality of determination that we have in our place. But that's also probably one of the most reasons why after this like movie we also decided to add another value, which is like very critical. It's like a teamwork. We value humble, hungry, and smart team players, and they definitely will find a great place in AlphaSense. Last but not least, we also operate at a very high speed, so it definitely never gets boring, believe me. So if it all resonates with you, then AlphaSense will be definitely a very exciting place to join. I strongly believe it is a very cool place to work, and you can see it on all these smiling faces pretty much like all day long. So yes, we are hiring, and if you're interested, myself, Oscar, who will present today, Juha from our talent acquisition team, also Tony here as well. Definitely, we're very happy to chat. If you might be not interested, then definitely still take a photo, share maybe with some of your friends, maybe like some ex-colleagues. Maybe they will find it a very great place to work. And yes, I think on that note, pretty much AlphaSense part is over. And yeah, let's welcome with a round of applause Lucas, who will tell us more about CNCF community.
Of course, when we had it off in the Okay. So, hi everyone. Welcome to the meetup from our part as well. Happy to see so many of you here. And me together with Mariam, Erno, and Gergely there are and Annie are organizing these. We try every month or so, more or less, in Helsinki. So that's all good. Then if you are watching the stream as well, then welcome to you as well. Thanks for watching. We have these meetups also in other places in Finland, in Turku and Tampere, and even across the whole Nordics, together with the kind of other really nice organizers in other parts. This kind of brings together the brand of Cloud Native Nordics as a whole. Couple of practicalities. Well, first, how many are here for the first time at these meetups? Okay, welcome. Nice to see so many of you. Yeah, short and sweet, we follow the CNCF code of conduct. Be nice to each other, be respectful. And glad to see that I think since last we bumped this number, and now 1,756. There was more than 200 more, so that's really nice to see so many people interested in this stuff. Yeah, there's lots of ways to join the community. I recommend that you check out the CNCF, so the Cloud Native Computing Foundation Slack, the Kubernetes Slack, maybe if that's interesting. Well, we're streaming on the Cloud Native Nordics YouTube, yeah, Kubernetes Finland on Twitter, all these kind of ways to get involved as well. Then we're always looking for more speakers. We want, this is not our platform. It's really your platform to communicate with other people and share your experience. So we want to hear from you that are doing different things in this area here in Finland. So we invite you to come and speak. We're happy to have good speakers today and are now planning the next one for April as well. So scan this QR code and let us know if you have something to share with this group. So a little bit about what is CNCF, what is kind of some foundational knowledge to make sure everybody's on the same page. CNCF was founded in 2015, so that's now some time ago already. Its mission is to kind of bring people together, a lot of companies together, a lot of kind of contributors, and kind of improve the developer experience around cloud native computing, such as, so we'll get faster code reuse, all of these kind of more efficiency, and then, reduced costs, all of kind of more agility and that kind of stuff. We'll look at where that comes from in a bit when going through the philosophies, but the main thing that's kind of for normal users, that normal users see is that CNCF has loads of projects, 100 something, 30, more 50. It's hard to keep. Sorry? Increasing every day. Yeah, every time we put the number here, it's outdated for the next meetup. But anyways, the idea is that we have sandbox projects for the kind of really new experimental stuff, then the stuff that the projects that a lot of people are using in production and is proven to be stable are then in the incubating phase, and the stuff that you really can bet your business on is in the graduated phase. So if we look at the projects, here is one of the snapshots from some weeks ago. We have already a lot of graduated projects. Well, you recognize Kubernetes maybe from there, Prometheus. There's, the lower part of Docker, Containerd is there, etcd, the data storage of Kubernetes, and so on and so forth. Lots of really interesting stuff. Then we also have the incubating projects, even more of them, and then not to talk about the sandbox projects, which are a huge bunch, and probably more since we updated this slide. But these are all kind of within the CNCF umbrella, and CNCF then kind of helps people come to a neutral place to collaborate together and kind of make sense out of this fast-moving ecosystem, right? So well, what does CNCF consist of? It's a set of kind of end users, a set of companies, a set of kind of technical architects, all kinds of contributors in the space coming together, creating different resources such as, well, end user radars, what are people using. Really excited to hear about, you know, one end user today, like AlphaSense, then making trail maps, so like, where do you start? How do you go about, if you're embarking on a cloud native journey, what to think about, what is maybe a good first path, that can be found in this trail map, and so on and so forth. Lots of certifications, trainings, and other community resources. Well, now we have 280,000 something, probably 300 more, kind of this massive online open course enrollments about Kubernetes for free. Make sure to check that one out if you're interested. Then there's kind of these real certifications as well, where you actually type stuff in the terminal and demonstrate your skills, and lots of other kind of tests and trainings you can do. Now we're kind of just taking a screenshot of this. Is not only Kubernetes, there's lots of other things, lots of good stuff to learn there. Really a huge community in all kinds of ways. So how to get in touch other than here? Well, I hope you keep coming to the meetup. These meetups approximately every month, but there's also other places to get involved. Well, the Slack communities, GitHub for all of the projects. Then they share a lot on their Twitter, but then there's mentorship programs if you're interested to kind of get started with Kubernetes and cloud native. We also have these kind of, well, these meetup groups. There's also kind of community days, community organized conferences every now and then. There was one in Norway a month ago or so. And of course, there's KubeCon coming in Paris for, what is it, 2.5 weeks or something like that. So how many are coming, by the way? Okay, nice. And I highly recommend that. It's really great. There's already 10,000 people registered. I think there will be 12 or so. So quite a huge place to kind of get to know stuff. Then finally, a little bit about kind of base set of stuff before we let these speakers loose here, talking about control planes of the future, a little bit more about the tech side of things. What is cloud native? What do we do? What is it all about? Well, if we break down the definition, which is quite a mouthful, well, it's all about building and running scalable applications, right? That's what eventually we want to do, right? So it's a way of empowering this. Where do we build and run these scalable applications? Well, hopefully anywhere, right? And everywhere. Okay, so how do we do that? Well, we can use, for example, containers, service mesh technologies, divide up our applications into microservices. All that kind of stuff are good examples of using cloud native, or kind of ways of implementing cloud native that are examples. But with this kind of mindset, with this paradigm, that is, well, a lot of things in it. We hope then at the end of the day get out a kind of resilient system so we don't have to wake up in the middle of the night from pagers all the time just because there's more users or websites or stuff. We want that to auto-scale, for example. So we want them to be resilient, manageable, observable. And last but not least, we want to be able to make changes and update our systems with minimal toil and kind of high frequency. So it's really a paradigm. It's a way of kind of organizing, it's a way of kind of thinking about the system that then is exemplified in these projects, how these projects are implemented. So it's good to shout out that cloud native is not containers. Containers is one implementation of the paradigm or of the mindset. That is one thing that kind of exemplifies this, but it's not only that. There's lots of other things out there that is really amazing. Also, cloud native doesn't mean you have to be in the cloud. It's really not at all that. It's a way, it's born out of the kind of mindset, it's born out of how clouds or kind of hyperscalers were doing things, right? But with your cloud native software, what we're gonna see today, you can run them on your own Raspberry Pi if you like, or in your own data center, or really wherever. Of course, you can run them in a public or private or hybrid, whatever cloud as well. But it's kind of good to keep them apart. Cloud is an economic model of should you rent or buy. Cloud native is a way of structuring your technical your code and technologies. Then what we're going to see here today as well is that interfaces or APIs are really the key part of this. This paradigm, if you look even in the CNCF, a lot of the projects are kind of doesn't ship with an implementation. Also, if we go to containers, well, that's a specification on that kind of governs what is a container. Or if we look at networking between containers, there's a specification CNI for saying that how should these talk to each other. Or storage, how do we get storage into the system? All this kind of stuff is just interfaces, and which lets people build lots of kind of interoperable implementations around this. So what we're getting at, and I'll leave you with this, but before we're going into the control planes of the future, but this is really the key point that Kubernetes is not the end game. Kubernetes is a platform on top of which you can build other platforms. And that is what we're going to see today. So it's a control plane where we can kind of program other types of kind of distributed systems on top. And now we have many good examples of what you can build on top from the speakers today. And by using Kubernetes, not everyone has to rebuild, re-implement the wheel from scratch every time. Because then it's costly and kind of, now we have Kubernetes, we can build on top of that and make that better as well when needed. So that's the kind of introduction. Now, next up we have some quiz questions to get us going before Oscar is going to talk. Yeah.
Right. Give a round of applause. All right, we also prepared a small activity for you just to warm up a little in the middle of the first part. And let me see if it works. Hope it works. Yes. Yeah. So please take your mobile devices and just scan this QR code. There won't be like any apps needed, just like you will log in to the website, and meanwhile I'll explain a bit more about the quiz. So it is like pretty much a short trivia, just 50 seconds per question, fastest and smartest wins. We also have some prizes for it, so I hope it will warm up a little as well competition we'll have here. And you just need to put your name there, register, so we should see people coming on the screen as soon as you do it. Who will be the first one here? All right, so Tony, Luke, Oak. Yeah, okay, I guess we're getting there. 51. How many will have?
I hope they don't rate like us.
Shouldn't. But it will limit you if you use ChatGPT. It will right away like minus 10 points, so do not try to attempt. All right, let's probably give it a couple of seconds more. And also for those who are online, please add some prefix that you're online, so at least we know that. Because we want probably to prioritize some prizes for people who are inside the tutorial later. And also people from AlphaSense, please do not try to win. So we'll give prizes to our guests. Right, let's mix. 70 and then we're good to go.
I'll give you a prize if you don't win.
All right, probably we should give it a 69. All right, I guess then let's go for it. Just again, speed is also very important. Not only like correct answers, but also speed. And there will be only 6 questions. Okay, 70, yes. All right, thank you for your response. For some reason, it doesn't work.
No?
Okay. Oh. What does CNCF stand for? That should be the one, right? After the first, after the previous presentation. We have 54, 60 answers. 63. Let's see. All right. 3% still missed it. So at least now like a very good learning so far after this question. Apparently it doesn't work completely, so I can stay here. All right. That's definitely correct answer. Cloud-native computing foundation. Kubernetes uses which CNCF project to store cluster data and maintain the state? So definitely who passed Kubernetes certificates or even like managed Kubernetes definitely should know the answer. All right, that was more complex, right? So then it's etcd definitely the right question. Which of the following is not a CNCF project? All the previous slides, they were very, very useful. So 4 seconds. All right. I hope nobody. All right. Even somebody voted for Kubernetes. Yeah, most of you handle it quite well. All right. So some surprises, but yeah. I hope at least it's not somebody from AlphaSense. That. Right. So, which of this project is currently incubating, not Craviotto and CNCF? That could be a tough one. All right. Yeah, that definitely was a tough one. So backstage is a correct answer. Flux and ArgoCD been created just probably last year, right? Or Flux and ArgoCD, like it was last year, right? And then, which project is a cloud-native storage orchestrator for Kubernetes? So we have 2 more questions to go. Right, that definitely was even more complicated. And the last one. What was the location of KubeCon Europe in the last year?
We need to clearly bring it to Helsinki again.
Yeah, for sure.
That was not the right one.
Yeah, that's more like a dream. So it's like 4% is more like our dreams, right? So, and probably people from AlphaSense who don't want to win. But yeah, so it looks like again majority made it. So let's see where we are. Yuko, Jai, Cooper, Nicholas, Lucas. Winners. Yeah, congrats. Who else? Right. So I hope that we have all 5, right, in the auditorium.
No, online. One is online. 2 is online.
Okay, right, 2 is online. So then, please, if you're in the, let me double check if we can check the. Okay, we cannot check. We'll try to find between the breaks. We'll try to find all the winners, but those 4, except online, please come during the break outside of the auditorium. There's like a proper table with the AlphaSense swag, so we will be waiting for you there.
With the prizes.
With the prizes, yeah. Maybe not only. But yeah, on this note, let's welcome Oscar to the stage and let's just give a bit of a round of applause for him too.
Can you hear me okay? Yeah? Or should I just take this off and... Nope?
A little bit louder.
Okay, so it's okay. Good. If not, anyway, So here we are to talk about the control planes of the future, but maybe we want to have a little bit of a look back into the past first. Anyway, I am here. Is this working now? Yeah, not working.
It's working today.
Okay. Okay. Now it's yeah. So anyway, I'm Oscar, and so I spent a lot of my life working with abstractions. In fact, I studied philosophy and theology, but I'm not here to talk about all those things, right? Though I was very tempted to talk about paradigm, and there's a little book called The Structures of Scientific Revolutions, which is really good about that. Anyway, but we are here more to talk about cloud, and obviously abstractions. And at AlphaSense, my work is to support the teams that help the rest of the engineering organization build, deploy, and run services. And so that's more like in a formal way. I work with the platform engineering and operation missions. And I'm here today to tell you how we got to this place. Of course, not this physical place, but how AlphaSense got to the place it is in it right now around platform engineering. And probably here we just need to quote some of the sayings that are often mentioned when talking about journeys. It is said that a journey of 1,000 miles begins with a single step, but it actually begins with a question, right? So the first question we need to ask ourselves is why, and the part that is important is why should we even start moving in the first place? Actually, why to any destination? And do we even know what the destination looks like? So bear with me as I try to share the whys that directed the decisions and the choices that we made on our own journey at AlphaSense. And so before I move on, I will have to at least address some questions. The ones that you probably have right now that is not necessarily about the journeys. Why the heck is he having this weird theme with papyrus-like feel illustrated with all monuments? In a sense, telling stories and asking for reasons, it is, especially when it comes about technology, it is like excavating and contemplating all structures and trying to make sense of them. A lot of the times we don't spend the time doing that, but sometimes we do. So looking at our past to understand the reasons for our choices, it's in a sense like doing a little bit of platform archaeology. Yeah, I know you were expecting to look, as I said, to the control planes of the future, but maybe we want to do a little bit of archaeology, at least on the history of AlphaSense itself, to try to make sense of why we made the choices we made. So let's go. Let's try to get that, and let's start with the first question. So why platform engineering? I told you that I work formally in the platform engineering and operations mission. So looking back, our AlphaSense, one of the reasons why now we're talking about platform engineering is because at one point we shifted left. That is, we started to move many things early in the software development cycle. And we started to ask teams not only just to develop software, but also to develop, deliver, and operate their services. That ended up adding complexity. Many of you might have seen that. Many of you might have suffered that. Most of you probably have solved all the problems, but at AlphaSense, we had a lot of complexity. That required teams to use and develop skills that were not their core business. That was a lot of work that created friction and additional efforts, and at times also a little bit of despair. Some of the people here in AlphaSense can probably agree to that. There is a note there just in case I forgot to tell what shifting left was, because somebody asked me. So the immediate key reasons for us to go into this platform engineering direction were, and still are, to reduce complexity, or the cognitive load. That is the complexity that fits into one's head, as one definition of cognitive load I read says. And also to enable teams to focus on our core business. That is to accelerate time to value for our users. So, in case you don't believe me, I wanted to bring some examples of that. So what does it look like? Where are we coming from? And why platform engineering? This is just an example of a service repository. There is a Terraform module. This is something that is probably common also on the infrastructure that you work with. But what is different here is that most of our services had a single module per service. That is, it wasn't a reusable module that you would actually bring. It was something that was created with a template and then would live there and eventually would get modified and maybe updated. Another thing that we had was also the Helm chart. The Helm chart also, Helm, one of the CNCF projects for templating Kubernetes manifest, was also living fully into the chart folder, into the repository. So just bear with me, as I said, please. We're just moving forward, and remember about this. What else did we have in the serverless repository? Well, we had pipelines for Spinnaker defined in JSONnet. By the way, Spinnaker, for those who are not familiar, as far as I remember, it's not a CNCF project, but it is a CD or continuous delivery pipeline project. It's fairly used in many organizations, and it's very good at what it does. But we needed to find a way to allow teams to define their pipelines as code. You'll see why we needed to do that. And this is, by the way, what the JSON template looks like. By the way, this is the one that lives there in the repo. And there are 3, 4 more. And interesting enough, this also has things that are not in the repo and that are very hard to find. Those are the imports that we do there at the top of the JSONnet. And nothing of this is obviously clear to the developers. What else did we have, or in some cases we still have? Bitbucket pipelines. Yes, we use Bitbucket. And not the last step there, Spinnaker. Yes, that's actually the one that would eventually deliver the software to Spinnaker. And that's all you know, basically. When you actually execute your pipe, you build, you Docker build, and then you fire and forget. Good luck with, with that whole thing going forward. So what happens? Well, this is what happens, and there is Spinnaker. So this is actually a partial view of the UI of Spinnaker showing the pipeline that actually deploys that particular component into production that has, yes, 10 stages. You can see the different stages here, some of them related to Terraform. So there is Terraform plan, Terraform applied, and there are other things as well. And finally, Kubernetes, and the red one, by the way, is Jenkins. Just that actually triggered the test and failed. So on top of that, we have one of these per cluster. So if you just happen to deploy to many places, that's what you get. And then what? Yes, Terraform. That actually Spinnaker calls cloud build. And not just once, but actually it has different runs for the plan and then for the apply. Yeah, now you're feeling the complexity, right? Now you're beginning to actually have that feeling of the developer. But why then did we expect teams to develop, deliver, and operate services and have to do all of this? That's a good question, right? Well, we also wanted to adopt DevOps. And now don't think it is yesterday. This is not something we did yesterday, but in the end, it was something we wanted to do as an organization. We wanted to optimize the productivity of developers. Oops, I got. To improve the reliability of our operations. And also, we wanted to be agile, like everybody else, right? Yeah. By the way, you know that in the beginning of agile, management, especially in large organizations, didn't want to be agile. No, it's a good question, but that's all right. It's a different presentation. So we wanted to be agile. We wanted to break the silos while at the same time moving everything into Kubernetes. So that was back then, 2018. So again, let me just give you a little bit of a sense of what the organization looked like back then. We had over 100 engineers in 2 continents, about 15 plus teams. There were also about 500 repositories of code and about 100 plus services in Kubernetes already migrated. And we always believed, you build it, you run it. That was the philosophy. Everybody was embracing that. So we wanted to focus on delivering value to customers. That's clear. That's what we were doing. And at the same time, we believed that you build it, you run it was probably the best way to enable that. It was the best way to do it. We just probably miss the nuances of that statement, maybe, and maybe not the so subtle dimensions of it, like we're not Amazon. That's one little detail. When you hear phrases and then you think, oh, let's do that. Yeah, remember, maybe that somebody else said it. like we did not have the actual experience with the decentralized model with these amounts of teams and these amounts of engineers. And probably we also weren't aware of the many complexities we were already introducing as we were asking people to migrate into Kubernetes. So we failed to ask why enough, in a sense. And so we're here to tell you, don't do the same. Okay? Start with why. And this is what we want to do today. In the little time that I have left, I lost track of time. You keep me. But before we move there, a little note on models, concepts, and reality. And I'm sorry, I said that I had studied philosophy at one point in my life. So let's start here. So what do all of these have in common? I hope you can see the little words, DevOps, SRE, Agile. Yeah, it's sysadmin even there. Some of us remember that day. Okay, what do they all have in common? Well, first, we can agree on what they mean. That's probably what. Every time you ask somebody, so what, one of these, oh, yeah, let me tell you the story, and then you start realizing, no, but I hear a completely different story somewhere else. That's one thing that they have in common. What else do they have in common? They have been declared dead at some point or another, right? So, by the way, that's supposed to be a tomb. Just saying because I didn't find the icon, and then so. Anyway, so this is the tomb of DevOps, SRE, Agile, sysadmin. They've all been declared dead, and believe me, platform engineering will also be declared dead. The CNCF will be declared dead. Everybody will be declared dead eventually. What happens here? Well, what happens is that we have models, we have concepts, and they are representations of reality. They are abstractions, right? They're not faithful representations that to the detail tell us how the world is. And in the best case scenario, they are useful, right? They allow us to benefit from the principles that they have acquired over time. And their utility, how useful they are to us, is situational and is context dependent. It depends on where you use them and what for. And so don't believe every death the agile industrial complex proclaims. Right? There's always an interest behind every death as every proclamation declared. Somebody's going to make some money. So sorry, I needed to say this because now I'm coming back to the question. So why platform engineering again, if we're not doing it because of all that? By the way, you don't need to buy platform engineering either, right? This is why the journey is important. In a sense, platform engineering in a nutshell, and by the way, there is a beautiful, we'll get there in a moment, CNCF platform special interest group that actually tries to explain, so what is a platform? And if you sum this up by asking ChatGPT, what does the CNCF say about platform engineering, then you would see something like this. Platforms reduce cognitive load, accelerate development, improve reliability, and enable efficient use of cloud services. But note one thing, this is not prescriptive. That is, this is not telling you what you should do. You should use platform engineering. This is mostly descriptive of what people say they use platforms for. And this is the page I was talking about, with a little bit of some overlay. But the main idea here is that at least they also started with why. They started with why platforms then. And this is a slide that is also part of the same white paper that I also very much like. I've been using this from the early drafts of what the platform looks like, what it is. And I like it because it helps immediately understand that a platform has these different layers, one made out of capabilities like infrastructure, like security, like observability, and another one, the interfaces. And on top, the users. There is a product and application teams that are the users of the platform, and that's why I like this. And I also like to use this to explain what are we doing in AlphaSense. How have we divided the scope of a platform in our case? Now, there we go. So the colors indicate a scope belonging to a team. In some cases, there are more than one color because the scope has been divided across some teams. At the moment, all of these 5 teams are part of this platform engineering mission. The core team, for example, owns the scope of infrastructure. AWS, Azure, GCP. Then we have as well for them things like security and other related to identity management and policies. The features team, that has a weird name. Every time we talk about that team, then people ask, oh, features or what? Is actually responsible for data messaging and, for example, Crossplane, that we will be talking even more on today. And then there are other teams. DevX, for example, as you can see, owns most of the interfaces, but there are some interfaces that have to do with Crossplane itself, and for example, those are owned by the features team. And then there is SRE with observability and QA automation as part of our pipelines. So this is a little bit about us, where we're at, what we are intending to do. This is 2024. We were looking at 2018. So what does AlphaSense look like today? 350 engineers in 3 continents. One of those additional continents is basically India, and there are a lot of offices there. About 50 plus teams, over 2,000 repositories, and yes, we have over 2,000 repositories, guys, just in case maybe we do need here people in AlphaSense, we need to do a little cleanup. And then we have 500 services, okay? So this is a little bit the scale at which we are operating at the moment. What we're doing today with platform engineering is inspired by that book that you can already guess which one it is. The 4 fundamental teams topologies. So team topologies inspired the conversation in AlphaSense already a few years back. And then for those who haven't read it, it's just a take on Conway's law and how to invert it. That is, if Conway's law says that your architecture, the software that you produce as an organization will reflect the communication lines of the organization that produces it, then what you need to do according to this book, and that's the intention of the inverse Conway's maneuver, is design the organization so that it produces the software that you want. And that's why it's important to also design your organization, but that's not the theme of this conversation either. It's only important because that's where platform engineer comes, and that's why we also made a decision to have a platform organization based on that. What else can we say about our own case? Probably that that decision was also the result of a reflection over where we were. And this is also an interesting graph that I also stole from Teams Topologies, where they talk about the different models for the teams that they suggest different organizations or have seen different organizations to have. And it's based on these 2 dimensions. One is the org size, or software scale, and the other one is the engineering maturity. And if you have an organization with a small size or software, with a small software scale or org size, then probably you have specialized teams that work together. If you grow in maturity, then you have end-to-end ownership, teams that actually own everything from the cloud all the way to the front end and the delivery of the system as well. And as well, well, that is actually if you have this sort of a small organization and yet high maturity. If you have high maturity and also a large organization, you have both. Specialized teams that focus on things like these complicated subsystems, but also end-to-end ownership over what is called the stream-aligned teams. And then finally, the specialized teams relying on a platform as a service as a model for organizations with large scales and maybe growing maturity, but not that high of a maturity, that has specialized teams that rely on a platform as a service. So not all cases probably work well with the platform as such, I would argue, but some do, and this is exactly the case. We are there, and that's why we chose as well to do that. So, sorry about that. I was actually talking with the team today, and we were looking at the different parts of our current platform, and well, PHACK is actually the acronym that, that the team came up with. So what is it made up of? Well, pipelines is the first one. We use Bitbucket. It could be something else as well, like GitHub. The implementation is not dependent on Bitbucket. And then Kubernetes are the P and the K. We're not going to be talking about how we actually operate clusters or deploy clusters today. We're going to focus on these center part, the half part of the stack, which is, in the one sense, one key aspect, Helm. As we mentioned, Helm is already used for templates and simplification of the complexity of a Kubernetes manifest for developers in particular. And we use it in a parent and child pattern that allows us to centrally develop and release it versus the original. I'll go back in a moment to what the difference is with the model. Remember that we had a chart that would live with everything in source from the day it was created, and eventually would drift, and we would have multiple versions across the organization. And then we went to a model in which, so this was a model that we had, and then we went to this. Simply, if you work with Helm, you probably know the chart YAML defines your dependencies, and you can, in a parent-child model, simply define your dependency, and the dependency could be a common chart. And that's what we decided to do in AlphaSense. So the common chart is a space chart, and then you can also have additional charts. And then the values files simply look like this. You're able to define your common values within it. So that's what happened with, and the main way in which we use Helm right now versus what we used to use. What is the A part of our platform at the moment? ArgoCD, another CNCF project, which is basically a GitOps engine. And in our case, we have one per cluster, and that's the model that we also use. There are many reasons for that, among them not having to create over 100 or 200 at the moment Spinnaker pipelines and stages. What does it look like in AlphaSense? Well, this is a little bit of a mix between ArgoCD and Bitbucket. And what we have done in this case with this is unify the interface in a Bitbucket pipeline. Yes, believe me, you can do that. Bitbucket pipelines used as the interface for developers to actually have full visibility over the delivery of the software. When they do that, they can, for example, either automatically, like in this case, or manually trigger that particular stage. In this case, deploy, for example, to a particular environment. That actually triggers another pipeline somewhere else, but that is not information that they need to worry about, but they can go check if they're interested in that change. That also listens for that event to complete. And finally, whatever the result, they will get that back into the pipeline. And what is interesting here is that they can also go check ArgoCD if they so want. So this is what happens with this pipeline, some of the examples of what are the changes that happen, and the structure of the repo is a little complex. Probably not the time here to go into those details, but it's basically based on the app of apps pattern in ArgoCD. Some of you, if you are using ArgoCD, might be familiar. That is, ArgoCD defines its own CRDs, their own custom resources that define the applications and how ArgoCD itself synchronizes to the source code in Git, and at the same time that actually defines how each of the components synchronizes. And that's what we have, and this is a model that we have on a single branch, on a directory per cluster, etc. So this is a model that we use, and if you would have seen the initial creation of this application that we were looking at the pipeline of, this is what would have happened the first time that it got added. There would have been also an automation that creates this in the repo. So this is ArgoCD, and the final C, Crossplane. In our case, simplify cloud resource definitions and management using GitOps was the main reason why we wanted to use Crossplane. There are people here who will actually give a lot more details later in one of the calls, in one of the talks. But why did we go with Crossplane? Remember, we were using Terraform and we were using Spinnaker. In that case, I already mentioned modules weren't reusable. We also had a different domain-specific language, the HashiCorp specific language that was not originally suitable for GitOps, at least not when we started all this transition. It also had a different state management. Everyone working with Terraform has probably experienced the pain of state management in Terraform. I put Plato there. You can ask me why later, but it's not Aristotle, it's Plato. Plus, there were security implications in our case. So what did we want when we studied out the transition? We wanted a single interface to define our services, just using the same model. In this case, a mixer of Kubernetes, but also Helm. We also wanted it to be cloud agnostic, if not at least multi-cloud. And we also wanted to have no additional state management. By the way, the cloud agnostic part just rule out the AWS controller for Kubernetes or the Google config connector, etc. And then we also wanted to have a control plane suitable for GitOps flows. So all those reasons were why we chose Crossplane. So we already had Helm, and then obviously we added Crossplane. And as I said, there will be people here talking more, and so there are a few maintainers now here and people working directly with Crossplane, so if you have any questions about that, they'd be more than happy probably to answer. So what are some of the things we're doing with Crossplane and Crossplane compositions? We are using it for defining databases across AWS, Azure, and GCP. The same for object storage, message queues, and also for IAM entities, the ones that we initially configure for Kubernetes to operate with, at least so far in Azure and AWS. And there are other cases that are part of directly interfacing with one of the providers for MySQL and using it for user database and grants, and that's one way in which our developers use it. But so how do the developers use it? We'll see it in a moment. This is just an example of the compositions and the definition of the composition resources. For those technical words, what they mean, as I said, we'll have the friends from Crossplane giving a lot more background. And looking at this, how does it look for a developer, which is in the end what we also cared about from the interface perspective. Just use Helm, and in Helm either integrate by bringing the database access chart and define what is it that you need access to, or define the cloud resources you need as part of our common chart, which has these cloud resources as a dependency, and simply define you need an object storage that works across the clouds, define the object storage, you need a queue, define the queue. The minimum amount you need is not even the name, but we prefer to have the name linked to the cluster name so to prevent collision if it is hard-coded there. Summing up, all models are wrong, some are useful. Start with why. In our case, don't let us just buy from the industrial complex, but let's ask why would we need to consume the things that are available, and then ask why again. Useful is relative to your situation, your context, the moment in your organization. Platforms work, or not. That's the thing that we're trying to find out. And by the way, I didn't mention that in detail, but there is, as well as part of the platform's special interest group, a maturity model that allows organizations to at least get a sense of where they are in this journey. When it comes to measurement, our level is 1. So I'm not going to paint a picture that is not. We are trying to learn how can we better measure the effectiveness and efficiency of the adoption of a platform in our organization. And then our choices were ArgoCD and Crossplane. I explained why, but also Helm as a way to form those choices. And it's a good foundation, but we probably need to continue to evolve that as well. And then finally, our journey, as we have said, is constantly becoming aware of what we have, where we are, and why we've chosen what we've chosen, so that then we can better understand what we need to choose next. So thank you. Time for your questions.
I guess we would have a 20 minutes break, right? So we can start at 6:30?
Yeah, we can have even more so people have time to eat.
So Yeah, let's at least have like 20, 25 minutes. And just a friendly reminder, please don't take the food inside. AlphaSense in place, trained not to let this happen, so
Yeah.
I just make sure that it will
Sorry, I just wanted to say if there were any questions. So I don't know if there's maybe.
Right, yeah, for sure.
No, because I know we are trying to follow that, but yeah.
Yeah, so I mentioned that you are templating this Helm,
Yes.
and apparently you are templating Crossplane plane. Is that right? So you're not templating composition, you're templating plane. You're templating the input.
Yeah.
Yeah, that's correct.
Well, but the composition is also part of the template because we, for example, pass using Helm the environment, and we define, okay, when do we use this composition? For example, it's a composition that applies only to a particular cloud provider, and in that case, we define that and enable that only for AWS. Or we have also different values that we want to have as part of the composition, for example, for production or development. So we use Helm as the main mechanism to define those type of things. So that's why we use.
So you're templating composition code as well.
We are templating but it's not the code itself. I would say it's the definition. It's basically going back to that particular example. Here you can see that, I don't know if it is seeing AX development cluster SQL. So then there is AS production cluster SQL. So it's not the actual composition spec that is templated in itself because it's not, that is the content of the template that basically uses conditionals to define whether that is enabled for that environment or not.
Got it. Thank you.
Yeah, there. Sorry, okay, sorry.
Yeah, so simple question, who owns the alerts for data storages, like database? Is it platform or is it development tools?
It is, that is actually a good conversation we've had recently with the team, that it is owned by this features team. So the thing is that the way that we are structured in AlphaSense is that we have the SRE team are the first responders. The responsibility of the features team, the one that actually handles these databases, even the ones that are created using these resources by teams, is to enable the observability integration so that then the alerts are created when the resources are created in a particular environment. And the escalation process should work, not always does, but should work so that then it goes first SRE, then SRE can escalate to this team. But I would say that there is still room for improvement, and people here from AlphaSense can tell that. Yeah, so there was some.
Yeah, so you mentioned that you have one Argo pair cluster.
Yes.
Can you elaborate your reasons for doing
Yeah.
architecture?
We didn't want, first of all, because we wanted to decouple cluster creation from any additional action that require, for example, putting credentials for that particular cluster anywhere. If you have a centralized ArgoCD management cluster, then every time you create a new cluster, you need to have a way to provide a mechanism to authenticate calls from that, your management cluster, to your satellite cluster. And we wanted to prevent that. And that's one of the reasons we wanted to do that. The second was we wanted to have a decoupled architecture so that then that management cluster wouldn't become the single failure, point of failure, which is the case that we had with Spinnaker when we were using Spinnaker, and we still use, by the way, Spinnaker. It's not like we got rid everywhere with Spinnaker. We do actually have a plan to get rid, and everybody's waiting for that day. So we have a countdown, right? Yeah, that's up there.
How many Crossplane clusters do you have?
Crossplane clusters, every cluster becomes a Crossplane cluster because we also provision the Crossplane providers per cluster. So we don't have, again, it's the same model that we use with ArgoCD. And that's why we enable specific things for that particular cluster.
So every workload cluster is also Crossplane enabled?
Is exactly, yes.
And how many was there? You probably had it, 50? Workload cluster?
No, workload clusters, at the moment we have approximately about 20. But they are not all productions. It's a little also complex because we do have also clusters that we model for customers, and we have here part of the team that is working with that additional project here too. So yeah, but it's about 20 clusters. Okay.
Okay. Then,
Excellent.
thank you very
Thank
much,
you.
Oscar, and then. Yes, so food should be over there.
Great presentation. Somehow I totally forgot about it. It's so easy.
I was, you know.
software enterprise. So, Jan, please introduce yourself.
Hi, I'm Jan. I'm a software developer in Cloud Prism. I recently started working on Crossplane together with Yury. Yeah?
Hi, I'm Yury. I work for Upbound. We are creators of Crossplane, and we are helping organizations around the world to be successful with Crossplane and control plane building. So basically, a little bit about real collaboration modes that we actually practice in real life for last half a year. We're lucky to have a shared customer, and this customer we cannot expose, but it is largest health insurance provider in the world. So pretty cool, large infra, associated complexity. And Jan was deployed there as a platform builder on the customer side, basically building a platform there and facing all this complexity and implementing Crossplane. I was on Upbound side, and I generally consulting people on generic effective Crossplane solutions, architecture patterns, and providing core Crossplane and official provider support. And basically, to simplify everything, Jan was poking me, and I was happy to make Jan happy. So that is the collaboration.
Yeah, so it seems that it worked well here because we are presenting together. So just to share a bit of our story. So we are migrating to Crossplane. So actually we have multiple teams collaborating. We already have existing product. Currently, it looks like that actually teams are exposing the REST APIs, and the customer can just make proper requests and create his needed infrastructure and applications. So we actually, a lot of our customers are actually developers. So we wanted to. That's why one of the reasons we moved to Crossplane was because we wanted to just follow the infrastructure as a code principle. We wanted also to allow customers for self-service with Crossplane. This is really nice because of the reconciliation loop, so that actually the resource can be reconciled. You can delete and Crossplane will basically recreate, and sometimes it can help. And also Crossplane, because of this approach with managed resources, it allows you to better observe the resources. And actually the solution which we'll be talking today about is the core solution in the client's company. So basically this we'll be talking about the solution which basically it creates the landing zone for every application which is deployed in our infrastructure. So we create a subscription or AWS account, and then network infrastructure, authentication mechanism, IAM roles, and so on. We basically allow other teams to deploy their applications, their resources, as well as external customers to also do the same. Yeah. But before we jump into this, maybe Yury can give us some nice intro to the Crossplane.
Yeah, totally. So before we proceed with a real implementation, I think it's important to lay out the foundational concept of Crossplane, right? So Crossplane, we're trying to reason about it as a framework to build custom control planes. So for control planes, what is control plane in general? So you know AWS, Azure, GCP, all of them are providing some form of API to consume the infrastructure. So you can build your own, and when you utilize Crossplane, most frequently you are doing everything declarative way without even coding. So you can build your very powerful custom abstraction to drive everything in a self-service manner. So a little bit about project history. So it's CNCF project contributed to CNCF in 2018. We are already focusing on graduation. So we applied for graduation proposal. So you can find it in GitHub. So please thumbs up this PR in CNCF repo. Pretty vibrant community, all the thousands of stars, a lot of members. So it's very healthy. So for the technical concept, first thing first, very basic managed resource. So managed resource is an actual representation of external resource. Usually it's some cloud resource, and with Crossplane, you can, with a Kubernetes, consistent Kubernetes style API, you can instantiate the resource in your Kubernetes API server. A canonical example for it will be like S3 bucket. So with a simple manifest, you make a kube controller apply, or you make it any kind of GitOps style, and associated Crossplane controller is going to shoot the external API call, talking to the cloud and basically converging the infrastructure. And with that model, you inherit automatically all the goodness of Kubernetes, reconciliation loop, automated configuration drift, everything's there. And thanks to, again, to the Kubernetes consistent API, you can observe everything like, Kubernetes style, status, event stream, everything going to be reported, your state of infra that is control managed. Yeah, so here we see like exactly the pictures that I described before. You instantiate the kind bucket, or it can be any arbitrary managed resource, and associated controller is going to talk to the external cloud API. Crossplane is built on top of very well tested Kubernetes machinery, well-known controller runtime, and a layer above is Crossplane runtime is actually providing the Crossplane resource model, the consistent way to talk to the external cloud APIs. And on top of that, you're building the set of providers. So that is already powerful, right? So you can control your cloud, anything external, with the Kubernetes API style. But there is much more in Crossplane, and it is composition and ability to build your custom platform API. So usually, even like with ability to build anything Kubernetes style, to provide something useful, for example, you need to expose a cluster to your end users, like cluster as a service, so database as a service. Usually they're not coming out as a single resources, right? You need to provide something useful. You need to provide a networking stack, security rules, and encapsulate all the organizational requirements into the single abstraction. So that's exactly what Crossplane enables you to do with the power of composite resource definition and a composition. And on top of that, you don't need to write any kind of generic programming language code. You define this logic in a declarative manner. So if to provide a picture, what is happening in a standard Crossplane scenario, you have usually some team that is consuming the infrastructure. Usually it is development team. So consumer instantiates the claim, and behind the API line, according to the platform builder created logic that is encapsulated within the composition, a set of managed resources are going to be composed and instantiated. And so this complexity is totally hidden from the end user, right? So that is to the cognitive load that Oscar was mentioning in his great talk. So more practical example. So claim here will be like some kind of small PostgreSQL server, and end user will be exposed to like something like region and a size of some minimalistic parameters. And these parameters that the things, the API fields that you expose, you as a platform builder, you controlling it. So you creating your very own API. And yeah, with this set of XRD and AWS composition, a set of highly interconnected managed resources are going to be instantiated, right? So it is RDS instance plus database, group plus security plus all networking, and everything, all complexity is hidden behind the single manifest. So that's the whole idea. So how you do it? As a platform builder, you're dealing, first thing first, you're dealing with a thing called XRD, composite resource definition, very similar concept to standard custom resource definition in Kubernetes. Also utilizing Open API v3 schema to define your custom platform API. So at this stage, when you apply the XRD as a platform builder, you're already extending your standard Kubernetes API server with ability to serve your custom API. But nothing at this stage yet implements the logic behind the API. So that's where the compositions are coming into play. And the compositions are way in Crossplane how you define this composition logic, like what is going to happen when you instantiate your custom composite resource. And composition is relatively easy, kind of YAML style DSL of composing resources. You can say like, create me database, networking and stuff, and everything in a consistent manner. In addition to that, we have a concept of patches. So basically, you propagate from your custom platform API fields down to managed resource layer, and that's how you create this data flow from external user that from the parameters that are defined by the consumer of your custom API down to actual composition and instantiation. And along the way, you can use transform to kind of massage the data and modify it on the fly. From a Crossplane extension standpoint, it's a very extensible framework, and we have 3 main extension points. One is providers, that is obvious, so provider AWS, provider Azure, GCP, etc. Virtually, you're not limited here in cloud providers or hyperscalers. You can create, you can interface with any API, assuming you have a provider for it. So we have an old blog post buying Domino Pizza with Crossplane. It was pretty like, it got some traction. A friend of mine recently created Spotify provider to converge his playlist in Spotify with Crossplane. I don't know why you need it, but it's possible. So that is providers. That is obvious external API stuff, right? Next one, the configurations. And configurations is probably most frequent concept that you will use as a platform builder. So that's a package, OCI compatible package, where you put your custom resource definition, your compositions, and you can distribute them via any OCI compatible registry. So you can push and pull and basically distribute your custom platform API across your organization. And the functions relatively new thing. So we originally have a very static patch and transform engine, and this function you can enrich it with a more custom composition logic. So we have a pretty rich ecosystem of the providers, and all of that stuff, all the extensions, providers, configurations, and the functions are available in Upbound Marketplace. So you can get there and install and find everything in a single place. So, and basically, Marketplace contains official providers that are maintained by Upbound, and also all the community pushing to the single repository, so it's pretty convenient. So that's for core Crossplane stuff. Now get back to the trenches, to the real project.
Yeah, so just to give you some idea, basically what we were creating in the real life scenario in the production. So basically the main managed resources, actually the main resources which we were creating was like subscription, IAM roles, virtual network subnets, network security groups, peerings, route tables, DNS zones, and on top of that, then the other product teams were adding their other resources like databases and whatever, like many different teams. And today, like we would like to present you like smaller example, but we would like to show you actually the things which worked for us in the real life scenario. And we would like you to join our team. Yeah. So without further ado, let's take the first ticket from our board, and yeah, let's go through it. So here we have the requirement: create Azure subscription using Crossplane. Yeah. So acceptance criteria is create, and subscription can be created and deleted. Other teams can create resources in the subscription, and this is Azure specific. Azure providers are registered. Yeah, so initial thought, how we can implement it, accordingly to what Yury said. Yeah. So we will just create XRD. We will create a composition and just create a subscription managed resource in it. Yeah, this is quite easy. Yeah, but actually Yury, maybe you can help us. How we can allow other teams to create resources inside of this subscription, because we don't want to give them some powerful service principle, yeah, to allow do whatever. We are the core team; they are just the product teams. So actually, what can we do here?
Yeah. So usually, how you define access in a cross-plane scenario, it's a set of provider configs, and you have a provider config for every provider you manage, and that's how you configure the credentials and access for this provider. What is capable to be accessed on a cloud provider side. So in this specific challenge, it is about creation of a provider config in a very dynamic manner. So you put a provider config as a part of a composition. It will be part of another compose resource next to the standard MRs. You propagate the credentials dynamically, and then you basically expose the ID to reference to your end users. So they can, in their compositions, they can just point to the specific provider configs, and there we go. They consume dynamically generated resources, and you will define scoping by Crossplane itself. So we utilize this pattern across our platform RESTs. Our canonical example is actually Kubernetes cluster as a service. We generate the credentials dynamically, we package provider config as a part of the composition, and then we expose it for provider Helm usage, and everything is ready for cluster.
So actually we use provider configs as a mechanism to authenticate ourselves, and we can also scope it only to the one subscription for it. Yeah, this is nice, so I like it. And in the meantime, where you were explaining us, I draw some nice diagram how we can do it. So here, guys, you can see this is basically the red box on the top is actually the claim for this account. Then below we have the XRD, X account. We have the composition which actually creates all the managed resources. And at the bottom we have all the managed resources which are created. Usages, this is some bonus. This is actually how you can orchestrate the deletion. So we just want to be sure that provider config is the last thing which is deleted, because otherwise you cannot delete. If you would delete provider config at the beginning, you cannot delete the resources during deletion. But so without so let's check out briefly the code. We don't have the enrollment account. That's why we cannot create the subscription. But we actually can create a provider config. We use the subscription name. We use the subscription the subscription ID as a name for this provider config, and then later we can that in this way the other teams can reference this provider config. We register needed providers for the Azure, for example, to create MySQL server. You need a provider SQL and the usage. Yeah. So maybe I can just show you. And this is actually how the customer will claim this account. In real life, if you would create the subscription, you can just add the subscription name. And also we are using composition selector because in theory we want to expose the same API, and we can, using labels, we can create account on Azure and or AWS, if you would like to. Yeah. Okay. So I think this is done. So what next? Yeah. So let's take another requirement. So actually now they want us to create virtual network, and I think this is quite easy. Yeah. So actually we'll do the same. We'll create separate XRD. We'll create this composition, all the managed resources. But actually there is one gotcha in this. For some reasons, they want us to follow very strange, very complex naming convention. And actually, Yury, maybe you have some ideas how we can actually achieve this in Crossplane.
Yeah, so this requirement of naming convention was a little bit tricky, right? So the situation here is that you need to propagate the data from a plane down to managed resource and get it back and transform, and again use it in a transform manner. So it narrows down to the problem of sharing data between managed resources. So to do so, we are using a pattern called bidirectional patching. So what we can do is, assuming we want to share the data from managed resource 1, we use a standard two composite field patch to propagate this data, the API value of the API field on the managed resource level to the composite resource status and store it there. And then with, on a consuming stage, we use from composite field path, very standard default patch type in Crossplane to get this data and effectively propagate it to the managed resource too. So you use this kind of round trip with the patch and transform engine. And along the way, you can use the transforms to actually create this complex naming convention on the fly.
Good, good. This is a bit more complex, but I think I get it. So just the overview. So we'll have the claim, very similar as before. Claim, composition. We will create managed resources, obviously resource group and virtual network. They will be using provider config created by the previous claim. Yeah, and when it comes to this naming convention, let's check this out. Yeah. So basically here we are. This is the claim for the network, and this is actually how the way how you are doing the bidirectional patching. So in the claim we have the full region name. Yeah. So, but later in the resources we need to include this short version of it, and also combine it with other parameters from the claim. Yeah? So actually this is how you do it. You are just introducing, at least this is how I'm doing this. You can basically do this on any managed resource, but I have introduced just like environment config. This is a resource which is core Crossplane. It's a little bit similar to config map, but it has also some extra possibilities. Basically, you can use it as your environment. But so yeah, so what I'm doing here, I'm doing the basic transformation. I'm just mapping the values, and I'm putting this to the XR. So like one level higher. Yeah.
Small details here. So when I explain bidirectional patching, I use a XR status as example, but Jan used metadata annotation on XR level, so you can store data there as well.
Yeah, this is like
if you don't want to expose the custom state.
And this is actually how you can consume this now. Yeah. So here we can see that actually this is the field which I patched before to, and now I'm patching from this field. Yeah. And in the end, I have yeah, maybe the example is wrong here, but it should be GVC1. Yeah. So in this as a result field. Yeah. So I think we have this naming. We nailed this naming convention. So now let's go. Let's go. Now we have something a little bit harder, even harder than this, because actually they want us to create subnets in these VNets. And those subnets has to be, they need to be created based on the dynamic input, which is an array of CIDRs. And also we would like to, have this somehow nicely, some nice interface over this, yeah? So, current state of our knowledge basically tell us that you just create like a bunch of MRs and hope that customer will never, reach the number, the maximum number. But actually, I believe that you have something extra for that, so maybe you can guide us here also.
Yeah, so the problem statement here is that in some situations, you want to create currently unknown amount of MR, so arbitrary amount of managed resources. So with the standard patch and transform engine, it's always predefined, so it's declarative. So you created like 1 or 2 or 3 or more subnets, but it's always defined as a static composition, part of the static composition. So how to actually iterate over a array type API field. So before Crossplane 1.14, before somewhere around November last year, and that's exactly like we implemented somewhere in the summer. So we had to use a workaround that I call this pattern abstracted helm. So basically you putting the provider helm behind the API line, and the provider helm utilizes this chart and does the templating and interpolates the managed resources in this arbitrary number of managed resources. And you basically put this very dynamic part as a part of composition next to the patient transfer. So I definitely I was using it a lot because sometimes you cannot find a way around it, but in very controlled manner, right? So only for the dynamic part of the API, the rest is declarative patient transfer. So it worked, but it definitely it introduced quite amount of complexity, a lot of layers, right? You have not only a XRD composition, you also have a helm release reconciled by provider helm, so kind of complex stuff. So luckily, after Crossplane 1.14, we got the functions in beta, and these functions we have this whole range of possibilities of extending standard composition engine, and we also released the function go templating. Basically, you can do standard helm style go templating for your compositions. And also, I need to mention it. I do not recommend re-implement everything in function with go templating. Patient transform is cool, but you still it enables you for this dynamic part of the API iterate over the array and then proceed with standard patient transform, and yeah, you can pipeline next to each other. You can start with patient transforms and proceed with the go templating, and basically offload on the dynamic part.
So you can nicely combine basically the old approach and the go
yeah, so basically function go templating enabled all a lack of conditionals and loops. You have them all currently available as a part of standard operations.
Good. So yeah. So and again, so let's dive into the implementation actually. So we have the claim which actually is already created. We have introduced the, let's call it sub XRD, which will be claimed by the parent composition. Under the hood, it is using the go templating function, and it's creating the subnets in the loop. Yeah. So let's check out how we can actually do this. So this is the composition which we already created. This is here. This is our internal abstraction called X subnet. Yeah, we can see that actually it's defined here. We have some parameters to it, and this is actually how we are implementing it under the hood. So this is the composition, but you have to check. You need to notice that this is in a special mode pipeline. As Yury said, that basically the output of the steps of this previous step is an input for the next step, and we are using here the go templating function. This is go templating language, and basically this is how you get the parameter from this XR. This is the array. We are iterating over this array, and we are creating the subnets. Yeah, so nice. So I think another task done, but now Yury, I think it's we cannot achieve this with Crossplane, because actually we need to peer our VNet to the VNet which we cannot import to the Crossplane, which is outside of our infrastructure in Crossplane. So actually we need, and we don't know its ID, we only know its name, or actually we only know the parts of its name. We have to somehow, or tags, something like that. So we have to somehow search for this VNet in Azure. And the problem is that there is this Azure Graph Query, Resource Graph Query API, sorry. But actually there is no provider for this in Crossplane. So what can we do?
You're making it harder, man. Yeah, so also very realistic situation, right? So there is some API and there is no Crossplane provider for it. What can we do? So one, I kind of this sequence in a level of complexity, right? So like a first thing, like a lightweight, you can hook in provider Terraform. And what provider Terraform does is it runs Terraform, it makes Crossplane running your Terraform. Also, be careful with it. Don't put every Terraform into Crossplane. Here we usually making it very controlled injection of Terraform into Crossplane compositions. And this is one of the great use cases for it. So this is a situation when we have a Azure Resource Graph Query API, right? No Crossplane provider, but there is Terraform provider. And therefore, historically, it's a larger community, so you can find stuff there. So cool. Terraform provider is around. We can use a Terraform workspace manage resource, create a very minimalistic Terraform code, put it into your composition, put it behind the API line. Your consumers will never know that it is some Terraform is running. And provider Terraform and Crossplane will endlessly reconcile your Terraform code, right? So you still have this automated configuration drift mitigation, all that goodness. So you're still within the control plane pattern. So that's the easiest way to proceed. Next level of complexity is to use Objet. Objet is our code generation pipeline. So you basically can take a Terraform provider and generate the code and create Crossplane provider out of it. Use our Objet provider template, and basically you can take, if something is missing, you need Crossplane provider for it, and there is a Terraform provider for it, it's a good chance that you can come up with a pretty good quality provider in a short time frame. And the last one, the most time-involving investment, if you want to write a Golang native code, you have a provider template for it, but it obviously it will require most maintenance, technical debt, all that stuff. So 3 layers of complexity. Which one you choose?
Yeah. So we've been developing for some time the custom provider, but we don't want to do this anymore. So actually, we prefer the easiest solution, which is actually the provider Terraform. So let's do this. Let's check this out. So yeah, here we have basically just added the virtual network peering and workspace. This is the managed resource which is delivered by Terraform provider. So yeah, let's check this out, how this looks. So this is basically how you use the workspace. So here you can see that this is the API version Terraform provider, which Terraform provider gives you, the workspace. And then actually you can inject either inline or you can have remote in the GitHub the Terraform code. We either can register the provider, the Terraform provider, which is for API for Azure Resource Graph Query, and actually this is the heart of it. We just make a query. We get an output of it, and we can reference the output in the patches. We can just take this out, patch it to the status, and then we can use it in another managed resource. Yeah, also here, this is maybe not the recommended way, but you can also do it like that. You can just use the Kubernetes secret to authenticate. You can do it either on the workspace level, which I wouldn't recommend, or you can either just create a provider config for Terraform and do it on the provider config level, which is, I think, better. Yeah? And now this is how we basically use it. So we queried we use Azure Graph Query, we get the VNet ID, and now with this ID, we can create a peering. So this is the peering MR, and we are using this field which we calculated as an input. We have this policy from field path required, which means that actually this peering won't be created before workspace. Will calculate the field, its ID basically. So yeah, I think it was hard, but we somehow overcome this. So yeah, thank you, Yury.
Yeah, maybe important part to add on this one is that you cannot block yourself immediately in this kind of situation with provider Terraform, but in parallel you can start working on generating Objet for creating new provider, but you have a stable API contract with your consumers, right? And so it will be already working. Whenever your Objet-based provider is ready, you can migrate your composition behind the API line. It's very powerful.
And also what I think what is quite important with this Terraform script is that actually we use it for read. Yeah? We don't create anything with Terraform here. Yeah? And this was actually our practice on the production also. We don't create anything with Terraform, but we actually use it only for read. Yeah, but now let's jump into how we can actually test Crossplane. So first thing which I have in mind, we can just create a bash script, kubectl assert, and yeah, we are ready to go. But I don't know, what do you think about this, Yury?
Yeah, we have some things available also in open source manner. So we have an Uptest. It's basically end-to-end testing framework that was created specifically to test cross-plane providers and configuration. So that's exactly how we in Upbound kept this velocity of developing official providers for 3 main hyperscalers and test them out, like a lot of CRDs and MRs there. And we also scaled this testing approach to the configurations. So the approach is relatively simple. So the test is kind of automations that drops a well-known CUTL, Kubernetes testing tool, and it generates the small minimalistic CUTL test suites in dynamic manner in reaction to cross-plane example. So like you have a claim or XR, and Uptest will generate a test suite dynamically. You don't need to maintain it, right? And it will basically instantiate the claim. It will check that, it will wait for the readiness, it will check automatically that all the managed resources are get it to the readiness state, everything is green, and then it will tear it down. So, and everything is available as a, with a GitHub integration as well, so like a GitHub action style, you can basically in every PR is additional command because it's heavyweight framework. We are testing our providers and configurations. So that's what I recommend to Upbound customers as well, to enable Uptest as a form of automated regression test suite and proceed with confidence. So it's really helpful. So that's what I recommended to Jan, but Jan decided to proceed with some more fancy way and create his own framework.
So we actually, because of the way how we create a lot of resources and with very specific naming convention, and sometimes, for example, we need to test this very specifically. That's why we basically used bare CUTL, but later we added like generation using the QLang, and we leverage basically that the QLang can import Golang, in which all the providers of Upbound are written, and yeah, this gives us basically the types, so it can be nicely combined and nicely generated. But this is the internal solution for now. But yeah, this is actually how we did it. Yeah, so I think this is it. So we have we shortly described our nice solution. You can guys find the code samples. We have the repo, it's publicly available. You can check this out. And yeah.
So all the abstractions in the public repo are ready to go. Just to conclude, so with Crossplane you can build your very powerful platform, API, custom abstractions, Java, shared experience. It can be really like a technical enterprise, great complexity. And yeah, it's very extensible framework. So even if you are blocked with something, you can always find some effective workaround, put again it behind the API line, and then proceed. So your consumers will always experience stable control. So yeah, that's it. Crossplane rocks. Thank you.
Thank you very much.
Questions you can take if you have time. We have time.
Questions, if any?
You said that users of Crossplane can have the revision process. How can we help?
There is a GitHub PR already with a document, right? If you can just thumbs up, it will be great. That's one thing. And if you are from a company who is using Crossplane, please add yourself to Crossplane Adopters MD. Create the PR. It will be like additional visibility that will indicate Crossplane adoption. So thank you for your question. Anybody else?
Could you please show the slide with adapters? That's one thing. And second thing, where you can get the list, like up-to-date list of already consumed.
Up-to-date list of what, sorry?
Of Crossplane adapters, like for
Providers?
For Prometheus.
You mean like a Crossplane provider? So it's marketplace. Can you open marketplace? You can just open marketplace in the tab. It will be better. Yeah.
Azure provider actually, but this is the...
Yeah, so we have like a Upbound marketplace where we hosting all the providers, configurations, and functions. You can find them all.
And this is the official provider.
Kind of like a Docker Hub.
Yeah, yeah, but for Crossplane Center, exactly. And it is OCI compatible registry as well, without Rails Unity. Yeah. Anybody else? Yeah. Yes.
Is there a way to build a bunch of resources all together, like a platform with Crossplane?
So you think like kind of large composition, or
Like the resources that you showed,
yeah.
For each of those, the user should make claims separately. Is there a way to deliver one whole bunch of those resources as a pack?
Yeah, totally. So like I will improvise here. Like we can get into any provider, right? And when we operating on a managed resource level, that's this singular, right? Like if you go to the
I mean, actually, because you have the account as a separate, yeah, you have networks separately, but you can actually create like a super composition,
yeah,
and put them behind some different abstraction, yeah? So actually, or you can...
So I was slowly getting, right? So this is managed resource representation. You can compose them in a higher level composition, expose like a composite resource. And this will be a highly interconnected part. But then, as Jan mentioned, you can even nest your custom resources into higher level composition. And basically you can create a composition of serious complexity, right? And deliver them all. You know.
You can actually have different teams maintaining different compositions, yeah? And you can orchestrate them on some higher level. This is...
But also in the simple case, even though you have only one plane, you can still generate arbitrary number of...
Yeah, this is basically here also.
How about with existing resources? Maybe I've created something with Terraform already, and I want to move it to use Crossplane. And also as a kind of side question to that, if I have a resource created in a Crossplane cluster, how would I move it to another Crossplane cluster?
Great question. So we have a thing called, so we have like a way to import resources into Crossplane. So Jan, if you can open docs Crossplane.io, yeah, you're reading my mind. Import existing resources. Yeah, we were working together for half a year, right? So we have this sync special annotation, Crossplane.io external name. So it basically represents the identifier on a cloud provider. So if you if you populate this annotation with this identifier, Crossplane provider will try to import the resource. That's how we import arbitrary external resources. Obviously, it can be kind of potentially dangerous. So that's why we have a management policies, and you can they are granular. So you can initially tell like observe, just import it, but do nothing. Do not overtake the control, and just you can get a feeling of the API. You can even play with the composition of it, and when you're confident, then you switch to full control, for example. So that's how you do it, and that's the same for the multi-cluster scenario, right? If you want to migrate, you just you dump the external names and then populate it at another cluster. And frequently, we actually exposing this capability in a composite resource definition to be able to enable users to do it, right? So like to override the external names and be able to import. Yep.
So to continue on the previous question, so say I have hundreds of Terraform modules and I want to switch to Crossplane or so is there a way to do this easily?
Yeah, great question. Unfortunately, there is no like automatic way to do it. So different concepts, right? Still, how Crossplane is doing things. So there is no, at least yet, automated kind of converter. But what I did with set of my customers, so I did the similar trick with provider Terraform. So assuming we want to migrate a model, we want to enable Crossplane like right away. We using provider Terraform, creating XRD, we creating this API, custom API, and abstracting complexity. And then one by one, we can can basically migrate these Terraform resources to Crossplane native providers, and that's how we control. We made this migration in a controlled way, and most importantly, we starting right away. So
this is actually how this is done also by some of the teams in our organization. Yeah? So they are basically running their Terraform scripts with Crossplane and slowly migrating to the native providers. Actually, one of the arguments behind this is that you have the Terraform state. You can, at least in my opinion, you have like better control over the resources because and they are better visible. Also, in our organization, we are using ArgoCD, so as a customer interface also. So this means that if you have like a workspace, you cannot see what is basically under the hood. Yeah? If you have native providers, you can see every individual resource, and you can delete it from the Argo. You can recreate it and so on. So this is awesome.
Yeah, I'll continue with the why. At the moment, we've been using Terraform next to Kubernetes. Terraform for provisioning the cloud resources, Kubernetes for just running the apps. So we want to simplify the user experience for product teams and move them totally on top of Kubernetes. Everything they can do through Kubernetes API. No need to touch Terraform. In the Terraform, we have a safeguard. When you are about to mess up, you are shown a plan that will tell you that if you press yes, I will delete your database. Now, moving to a declarative Kubernetes, you can achieve the same thing by moving a file from one directory to another, for example. What are your recommendations for safeguards in this situation to prevent users from hurting themselves?
Yeah, that is a great situation to tackle. So basically, one of the main things that I hear, like, can you make a dry run, like Terraform plan can do? They're like, no, you don't want to do it. You want to test your abstraction configurations. And that to all the stuff that we described today, everything is granular, right? So you can use a test framework to make an end-to-end test on every piece of infrastructure, like everything is nested. And this way you actually predict the behavior and regression test it. That's one thing. Another, there is a implementation detail to that, like deletion of the database, super scary stuff, right? Yeah, so what we have in official providers, we have embedded flag, let's say, that stops for destructive operation, unintentional ones. So it will never delete the database, it will just provide the event, destructive operation, I figure out, it's conflicting is a desired scenario.
You can, and also depends, I think, how you apply the claims, because, for example, if you are using ArgoCD, let's say, then you can actually, then when you are deleting some managed resource, the customer has to confirm, that he wants to delete this. So we can also maybe leverage this level.
Yeah, and obviously, like a standard classic recommendation, do a healthy GitOps flow, right? So you have this audit, and you have everything is done through PR, so there is no chance for accidental removal of whole manifest, right?
And there's also in Kubernetes just generally this admission webhook or kind of admission control. So before putting anything into the cluster, you can have whatever policies like in Kubernetes or something similar, so that you can, if there are specific configurations that you want to prevent against, then you can create policies and say that, well,
yeah, but
don't at least do this.
But this is actually a valid question, because we are also basically currently we are also checking out how to exactly answering your question currently. Yeah, we are having also this problem.
Actually, just to reflect back, what we are considering is one, disable destructive operations by default, the option that you proposed, and the other is some kind of mechanism for easy recovery, so that user can do whatever they want to, but we have their back in case they need it.
But also, this basically to disable the destructive operations. You can also use this, management policies.
Either management policy or deletion policy are fine.
Yeah.
So you can tell like to super important database, just never delete it whenever it's getting deleted from Kubernetes API server. Yeah.
Any other questions? There?
Yes.
Yeah, well, thank you for that great presentation. The context, this question is in the context of AWS essentially. So if I have a cross-plane management cluster and I want to manage AWS resources in multiple AWS accounts, how would I do that? Is that possible? Let's say I want all the developers to, for example, create their database in my cross-plane management cluster, but I want them to do it in a separate AWS cluster, which is outside the whole Kubernetes environment.
So is it multiple AWS accounts or multiple clusters? So multiple AWS accounts is basically different provider configs, right? So you propagate, you can have a multiple provider configs and you can reference them. So if you want even like a single composition, you can target multiple accounts. No limitations there.
So basically, you can use ISA as a authentication mechanism. Yeah. And then later, also, yeah. So this is one, and based on roles, you can basically do this. But also, you can even on the provider config level, you can basically provide the account ID, and then also this should be doable in this way. Yeah? So very similar as we did here. So basically here I'm using those credentials. Let's say those credentials are this is on Azure, yeah, but this is quite similar on, let's say, on AWS, that those credentials are, this is the service principal who has access to some kind of, to many subscriptions, let's say, yeah? And it can create resources in many subscriptions, but I'm actually scoping it only to this subscription, which I have just created. And this is and only this I'm exposing to the customer, yeah? No, I mean, nothing else, yeah?
So there was a question.
Yeah, what about the API server? I mean, at scale, so there could be hundreds or even thousands of these custom resources. And the API server is certainly not happy in some cases. So what is the current guidance?
Yeah, totally. So we had like a serious problem with that because thousands of CRDs and Kubernetes API server just not designed to handle them all. So that's why we introduced these family providers. That's why with the entry points is like a family. We have, so basically, it's instead of providing the monolith, like thousands of CRDs for AWS, we are splitting them. It's exactly the same code base, but we are splitting the build, and we are providing the service scoped provider per cloud service. So like EC2, S3, all of them will be different providers. Within the same family, so they will share a provider config. So you just, you can cherry pick, and this way you can operate beyond this, dangerous threshold. So that's the current approach.
But maybe to answer, that is on the CRD side, but then to answer how many objects can you have there, the existing limits are the ranges of hundreds of thousands of pods, for example.
Yeah, but then also your cluster has to be very powerful. So because we also had this problem, so actually our not my team, but the DevOps team, they came up with the solution that actually they are cherry picking from Upbound official repo, and they are building the providers on their own. So for example, they have Azure provider, and based on the PR, you are just providing the list what managed resources you want to have, and they are building the provider themselves. Yeah. So this, for example, this helps a lot. Yeah.
Yeah, I figured also if you enable APF and if you delve into APF and correctly set all these full schemas and stuff, so it's not the total number of objects, but more so about the performance and the number of changes at the same time.
Yeah, that's right.
And then there's always that Upbound cloud, right?
Yes. I'm not allowed to talk about it at this specific event, but thank you so much.
So let's say you have a composite resource definition, you've developed it, it's been there for a while, people are using it, and you realize that you want to make a version 2 and have some breaking changes. How do you orchestrate the update?
We want to share the story.
Yeah, this is actually, we also had this story, so depends, this is breaking change, yeah?
Yes.
So if this is breaking change, so actually you need to introduce, because actually you have the versions here, yeah? So this is the version. So, but actually if the change is a breaking change, you need to introduce the separate API version here, actually, yeah? So you have to put it there. But actually, we were talking about this last time. What you can do to prevent this in the future, actually, you can wrap your. So this is our claim for the account, yeah. So now, if I'm doing some breaking change in the XRD, which is under this claim, this is directly exposed to my customer, yeah. So, but if you would wrap this with the super composition, you would wrap this around like the next XRD. You have some, yeah, you can do it, yeah, and you have some idea, so some possibilities to, for example, provide some default value. So let's say you are introducing here, let's say, subscription name, and you want this to be required. Yeah? Currently, there is no way to do this, yeah, because you have 100 customers who don't have the subscription name. So suddenly, all those claims will be not ready, yeah. But actually, if you would wrap this before, yeah, you could do this.
So the answer is kind of don't do this. Okay?
Yeah, this is.
You can serve like both two versions within
that's
XRD,
kind of the
right?
question.
Yes.
So if you want to migrate from V1 to V2, and what do you tell people to do and how?
Yeah, so there is can be easy migration, so you can have a ability to co-maintain like an old and new API field. So for the time being, it's kind of it's not super nice, but it is the situation. So when you migrate everything to the new API field form, then you deprecate the old one. So it's ugly but straightforward, and it works.
And the Kubernetes API supports multiple API versions natively,
So it's kind of similar.
Yeah, and if you then have a would build a small migrator, then you can kind of read the old objects, write the new one in the API version.
If to even go even more complex scenario, you can write a webhook. We have a available example of webhook, but then you are in the story of maintaining the webhook, right?
So same as
Conversion of
Yes.
Exactly. So here we are totally dependent on Kubernetes machinery.
Yeah, there was a lot of questions. Thank you very much. And
thank you guys.
Also,
thank you for the questions.
Also, thanks. I forgot to mention that Yury flew here from Prague, and then Jan from Poland as well. So very thankful that they came up here.
Thank you.
Hi. Yeah. All good? Or yeah. Is it working? Yeah, actually, sure. It's so late, everyone's just gone home. But yeah, thanks for being here. And yeah, this is my first time talking here, actually. So. Thank you. So, but if you hear me trembling, then just ignore. Thanks. All right. So my name's Huy. I'm from Ericsson, and I'm actually working for Ericsson Software Technology. It's a company belongs to Ericsson, but we mostly work on Kubernetes related projects, open source. And the project that we spend most of our time with is MetalCube, which is if you work with Kubernetes and you work with bare metal hosts, you might have heard of us because there are not many choices for that out there. Today's topic is about future control plane. So we want to present our recent study regarding using what is so-called tenant control plane from Kamaji. What it means is basically just running control planes at ports. And yeah, let's dive in. So first, I want to introduce a little bit about MetalCube. We are a project that handles bare metal provisioning on Kubernetes. And MetalCube has a cluster API provider. So I hope that everybody is familiar with cluster API, but if you are...
I think if you can tell a little bit about it.
Yeah, if you are not, then cluster API is a SIG project to provision cluster, Kubernetes cluster, the Kubernetes way. So basically what it means is that you have one bootstrap cluster. You can create it on Minikube, on Kind, or anywhere. Then you install Kapi or cluster API, and then Kapi will help you to provision different kinds of Kubernetes clusters in everywhere.
So you can, for example, provision it on AWS or Google Cloud or basically anywhere Azure. Yeah, and the way that Cluster API does that is that it passed out the job to the specific providers, which are the actual things that handle the logic of each of the platforms. So for example, for AWS, we have a provider for AWS, and of course another for Azure, another for Google Cloud, etc. And for bare metal, we have MetalCube, and MetalCube is actually the provider that works behind the scene when you run Cluster API on top of a bunch of just bare metal nodes as you want to provision as Kubernetes clusters. So yeah, I will come back to that in a moment, but yeah, let's go. Yeah, so basically in a typical MetalCube clusters, we will always have both the control planes and the workers as the bare metal host. So basically if you have like 4 bare metal nodes, then at least one of them should be the control plane and the rest can be the workers. And here, yeah, we have a website, metalcube.io, if you would like to know about. By the way, the name is MetalCube because we actually want to put the number 3 on top of the metal word. So that is a wordplay for Kubernetes. But nowadays, I think most people just call it metal 3. Okay, here's the components. You don't need to remember this. This is just for introducing the project. So basically, we have the Cluster API on top, and then Cluster API will talk with the Cluster API provider Metal3 or MetalCube, which also called CapM3. CapM3 will talk with another MetalCube component called bare metal operator. And bare metal operator is the way that Kubernetes cluster can handle the bare metal nodes provisioning by passing down all the commands to another operator called, or not operator, but another application called Ironic. And that's what handles the job. Now let's talk about Kamaji. Kamaji, as I mentioned earlier, is the project that handles Kubernetes control planes on pods. Control plane pods. Standard control plane is actually the name of the CRD that Kamaji uses. But you can see also similar concepts in, for example, Hypership. They have something called hosted control plane, and I think similarly, they use like similar structure there, even though I of course don't know how the code in Red Hat is done, but yeah. So something, yeah, they also have on website, and if you look at their logo, you see that they have like basically a face with some mustache, and it comes from this character. This one is a character from the anime called Spirited Away from, sorry, forgot about the studio, but yeah. Ghibli. Yeah, Ghibli, yes. So yeah, so basically this one, I watched it a long time ago. I don't remember everything, but this character is basically one person that handles all the things behind one hotel. So normally you never see him, but everything that you do in that hotel is managed by him. And if he's not there, then nothing will work. And you can see that he has many hands, and he does all the stuff. So basically, I think that's why Kamaji decided to choose this name, and they also wanted their provider to work kind of the same way. So, yeah, so here's, sorry, it's a bit big. Let's see if I can make it smaller.
Yeah, so basically the way it works is like this. You have the one big cluster, like the management cluster, but inside the cluster you have some tenant control plane for different clusters. So these workers of these clusters are actually outside of this management cluster, but all of the control planes will live inside the management cluster as pods. So basically, yeah, just as I mentioned earlier, it's just a way to represent it in a diagram. Okay, at this point, one question might arise is, why does it matter? Or why to use Kamaji in bare metal? Because, yeah, of course, it's nice to have control plane at pods, but why? Why for bare metal? To answer that, let's go through the typical metal cube. As I mentioned earlier, we have basically one management cluster, and inside that we have copy, and we have metal cube, and we also have bare metal nodes which live outside the cluster, but we can use the cluster to provision it. Sorry, them. And basically, at the end, we expect to have, for example, in this case, we have two bare metal nodes. Then we expect to have at least one control plane. So yeah, so this is one way to describe it. We can have a cluster with one control plane, one worker, or we can basically have two clusters with one control plane. Of course, you can also have one cluster with two control planes, but you get the idea. So always at least one control plane. But then if we have Kamaji, then things change, because now we also have the tenant control plane inside. And for that, we can basically have more workers. For example, here, in this example, we have two clusters, but both of the bare metal nodes can be used as worker nodes. So in a way, it increased our computational resources by delegating the control plane to the management cluster. And of course, Kamaji also has the other fine tuning features like share SCD and stuff. But yeah, you can also investigate more if you follow their repo and docs. So basically, what Kamaji offers is saved resources, as I mentioned earlier, and it reduces operational burden because now you don't need to have like separate bare metal hosts for control planes. And we're talking about bare metal, so sometimes it's very expensive. It's not like cloud where you just can create a small VM and use it at control plane. Here it's a bit more expensive. Yeah, and it speed up control plane management. If you want to upgrade it, for example, you just create a new pod and assign to it. Versus in the bare metal way, you will need to turn off that machine and then provision or install a new operational system and then install new Kubernetes and etc. It takes a lot of time. Here it's instant. Greater flexibility. This one is, of course, related to how bare metal is. It's basically just machines. So you cannot change it easily as pods or VMs. And yeah, so basically that's, it's also easy to manage because for example, if you have multiple clusters, you have all the control planes in one place. We can go back to this in later, but right now, let's go into details how we do that. So we spent quite some time on investigating how to do this, but basically it's just to, yeah, so the setup is that we only provision worker nodes with MetalCube, and we use Kamaji for control planes. we will have Metal LB as a load balancer to provide IP for the control plane, for the Kamaji control plane. Actually, Metal LB is one of the suggestions from Kamaji to be used with their own control plane, and that's why we chose it. In MetaCube, normally the IP is handled by our IPAM or IP manager, IP address manager. But in this case, we cannot use it because we do not have bare metal control planes in place. So the way we do it is basically we assign the same IP to we ask Metal LB to us. Yeah, sorry. Okay. So basically, we ask Metal LB to assign the same IP. Sorry, not the same IP, but to assign an IP, and then we assign the same IP to the service address, which is basically what the API server. Sorry, the API server is down here, but this is what Kamaji expects, and then this is what the copy will expect to ask the API server, because in the end, copy wants to know if the provision succeeds, so it can just send requests towards the new cluster API and ask, hey, are you okay? Are you healthy? And so that's why it needs to be here. So yeah, yeah, I will basically have a demo here to demonstrate what is going on. Yeah, let's see. So the way it works is that this one is the in lifetime, so I didn't just increase the speed or anything, but because it will take a lot of time to provision, so I will just skip forward when there's something is interesting to see. Basically, now if you this few commands is just to show you that the management cluster or the cluster that we have here basically is a Minikube cluster, but it doesn't have anything. It just not doesn't have anything, but it has only the predicate of the MetaCube. So it has Ironic, it has cert manager and bare metal operator. It doesn't have cluster API or KPM3 or Kamaji. So that's basically where we will start. It also has some bare metal hosts. Sorry, I'm not sure if it's already here. Yeah, now. So it already has 4 bare metal host objects. These are basically the Kubernetes representation of the real bare metal nodes that we are about to provision. Now the states say available, which means they are up for grabs, but they are not provisioned yet. They don't have operating systems. They don't have anything. They are just the nodes. But in the end, we are supposed to turn these into Kubernetes nodes, and it can be control plane, can be workers. So yeah, let's go ahead and see what. Here we will run a setup script, which basically install copy, KPM3, and Kamaji. Basically, if you're familiar with copy, it just means that you run a cluster kernel in it, and then install Kamaji, and then create some clusters. And on the right-hand side, you can see that we have a bunch of watch commands to see what the cluster resources will look like. So at the end of the script, at the beginning of the script, we only have the bare metal host. We don't have any. Even the CRDs were not defined there. But yeah, let's move to the end and see what it's like. Sorry, don't know where my cursor is. Yeah. Okay, so now you can see that we started to have the tenant control planes, and they are now in provisioning state. So if we skip forward a little bit, we see that all of the tenant control planes are provisioned. And at that point, the metal cube or the metal cube components start to provision the real bare metal host. So they know that they have the control planes, so now they can provision the workers. In the real or in the typical metal cube setup, we normally also provision the control plane first, and after that, the workers. But in here, we don't use metal cube to provision the control planes. We only use it for workers. And you can already see that the bare metal host states change from available to provisioning. It means that it's started to be provisioned. Now, if we fast forward a little bit, then we see that all of the bare metal hosts turn to provisioned. It means the provision step is done, and the machine objects, which is the copy objects to represent the real machines, are now all in running state, and they all have the provision ID, which means that they are more or less ready as the Kubernetes nodes. And if you see that the metal cube cluster now all have the endpoints and all have names. So it's more or less done, the provision. Strip is running. Okay, so now we can check what it looks like. In copy, there's an object called clusters, and you can see now we have 4 clusters in this management cluster. And with these 4 clusters, we can basically do things like we can get their we can get their kube configs. So in here, we just have a basic loop to get all of the cluster kube configs and put them into files. And with that, we can do the things that we normally do with any cluster. We can check their resources. And in here, what I did here is just to check their nodes. So for example, you can see in this node, this cluster, the node, there's only one node, but the node doesn't have any rows. It means it's not a control plane. Yeah, I think I also have checked the management cluster node in here. Let's see if I can fast forward. Yeah, so in here, I don't put any kube config. So it means it's using the default one, and it's the management cluster. And you can see that it also have one node, but the node has a rows control plane. So it means we successfully provision some cluster without using any nodes as the control plane. All right, I guess that's enough for this. Let's move on to the next one. So now the next question would be, doesn't having many clusters makes management harder? Why don't we just have one big cluster and put, like, for example, one tenant control plane and 4 workers? Well, this is actually a valid concern. And when you have one cluster, it's always easier to manage, of course. But it also has some catches. For example, in multi-tenancy, if you have multiple users and you want to separate their resources, it's way more difficult if you only have one cluster. And it's always safer and easier to have separate clusters for them. And also, there are some other use case that we can take an example next. But in the end, if having one big normal cluster with multiple nodes, multiple workers work for you, then it's fine. It's great. But if not, then yeah, we will have some more solution in the end. So now let's have an example of the use case. For example, if we have multiple bare metal hosts and we have them in various locations with various size and latencies, and we want to manage them centrally, and we want to have application resiliency, which means that, for example, if one worker is cut off the network from the cluster, then the application in that worker should continue running. And when the connection is back, then it should happen that it should act like nothing happened. It shouldn't just kill up that cluster or do anything. So yeah, so we have here a couple of options. We can either have a normal Kubernetes cluster, or we can have some multiple remote clusters. So let's talk about normal Kubernetes clusters first. Of course, it's going to be centralized management. We only have one endpoint, but it doesn't really, or most of the time, it will not handle the application resiliency very well, because of course, it depends on your use case. But most of the time, when you cut off one node from a multi-worker cluster, the control plane will just assume that that node is deleted, and it will set a deletion state on all of the ports on that node, and basically assign those ports on another or other workers. And when the connection is back, then it will just ask the worker to basically delete everything. That's not what we want in some cases. So yeah, for remote clusters, we don't have centralized management, but we do have application resiliency because the cluster only has one worker, so there's no way it can be assigned to anywhere. So yeah, basically the way, the morale of this example is just to show you that it happens that sometimes we would like to have multiple clusters, not just one. But the lifecycle management is a bit difficult, of course, because while Kapi offers various ways to provision clusters on the lifecycle management of the cluster level, but on the lifecycle management application level, it's a bit lacking. Yeah, so that's why we have this new concept called multi-cluster management. And it's not, I guess it's not very new. We have Kube Edge and, sorry, forgot the names of the Kube Admiral, right? Yeah.
Back in the day, like in 2016, it was called Federation.
Yeah, right. Kube Fetch, sorry, yeah, I remember that name, but somehow forgotten. Yeah. But basically, there's a, MCM is the idea of having multiple clusters managed centrally from one management cluster. And there's actually one SIG group called Multi-Cluster 6, which nowadays standardize and coordinate different practices around this multi-cluster management. They are actually the authors of the Federation project and KubeFed later on, but both of them are now retired, and the SIG group mostly focus on creating the standardization for other projects to follow. And nowadays there are at least a dozen of different projects that handle the thing. Yeah, so I think it's worth mentioning some basic ideas about this. For example, the push and pull modes. So this, sorry, still a bit too small. Make it. Okay. So this image is taken from the Kamada project that we are about to discover later on. But right now, let's see the bottom part. You see that there are two member clusters in this case, but they are connected to the management cluster in different ways. The cluster 1 is basically doesn't have any extra thing inside it. It only so the management cluster has the access to the member cluster group config, and it basically just push down the commands to that member cluster. But for the cluster 2 in here, we also have some Kamada agent, which kind of like a group ADM or running inside the second cluster. So from time to time, it will report back and receive requests. And if the network is cut off, then it can basically handle the things on its own and kind of stuff. So the reason I want to show you this is to show that, yeah, so basically the difference between push mode and pull mode is a trade-off between less resources and more reliable management. But because we have Kamaji control planes centralized inside one cluster, it's allowable for us to use the push mode in this case, so that we don't have to install anything extra on the member clusters. So basically, you won't be able to manage multiple clusters as if they are one cluster, and without the cost of installing anything extra on them. So yeah, here's one demo about this. Let's see if I. So let's recall a little bit about at the end of the last demo, we have 4 clusters, 4 member clusters, and we have the group config for all of them. So now, if, what we will do is we will install one script that basically install Kamada on top of the management cluster, and then join the 4 member cluster on it, and then we can basically see how it works. Yeah, let's move on to the. So at this stage, we see that everything is joined. 4 clusters joined successfully, and on the right-hand side, we have some watch command for each of the member clusters, and you can see that right now they don't have any deployments. Okay, let's see what we can do with them. So now, here's the way to show the member clusters. By the way, we are using a different group config here because Kamada kind of install its own API server, so it will expose on a different port. That's why we need a different group config, but it's still the same management cluster that we had earlier. And
the clusters like Kamada?
Yeah, sorry, Kamada, yeah.
Is it their own type? Is that a kind of
yeah,
extension?
Yeah, it's I think it's an extension, but it exposed the API to another port. Yeah. So yeah. So let's start with installing one deployment on it. Yeah, basically now if we install one deployment, you can see that nothing happened. If we check the management cluster, we see that nothing is running, but it shows that there's one management cluster, sorry, one deployment there. And yeah, so now we can start playing with it by using something like co-propagation. So sorry, I need to pause it a bit to explain. So the way this propagation policy works is that it will have some reference to the deployment or the resource that you want to propagate to all some of the members, and it will have a list of clusters. So for example, in here we have cluster 2 and cluster 3, I think. 1 and 2. So if we apply it, if we apply it, we see that soon the cluster 1 and 2 on the right-hand side have that deployment. And then we can start play with it. Now we check the deployment on the management cluster. We see that there are 2 ready and there are 2 up-to-date deployments. Now we can change the cluster. Now instead of 1 and 2, I will also add another cluster, save it, and reapply it. Now you can see that the cluster 3 will soon start to have an Nginx. And yeah, you get the idea. So basically, if we change the cluster, then we get then the cluster that no longer has that deployment will be deleted. Sorry, not the cluster, but the deployment on that cluster will be deleted. And if we basically put all the clusters here, then we will have all of the deployments on the right-hand side. And if, like, for example, we don't put anything, then it will be applied to all of the member cluster. But if we say put a cluster that is not one of the members, then it will not install. It will not be installed in any of the members. So yeah, I guess you get the hang of it. Basically, this is our way to manage the multiple clusters. But as I said before, it depends on your use case. Sometimes you just want one big cluster. Sometimes you want multiple clusters. And if you do, then this might be one way to solve it. So yeah, I think that's the end of the presentation. And yeah. Yeah, any question?
Yeah. You go first.
Metal tree question more about, you mentioned that it's using the OpenStack ironic underneath, so does it require an actual OpenStack installation, or can you just use it?
No, you don't need OpenStack. Yeah, ironic is installed, like you can install it locally as Docker containers, or you can install it on the same management clusters. Yeah.
Cool. Thank you.
Yep. Yeah.
There was mention of the Kamaji shared data store or something like that.
Yeah.
Do they use something like Pine, like shared SQL, or is there an etcd per API server for the control plane?
I think they have one stack of etcd by default. So I think by default it has like 3 ports. And even if you increase the number of the clusters, you still have 3 ports. Of course, that number can be changed.
Okay, so they kind of dedicate prefix for each control plane in the etcd kind of place.
I don't think it's per control plane, but it's like shared between the control planes.
Yeah, exactly.
Yeah. Yeah.
Since you demoed deploying the same service to multiple different clusters, is there a built-in way to do load balancing between the clusters, or is that something left outside this setup?
I don't have it here, but Kamada does offer something like that. Yeah, you can basically load balance by I think reasons and size and different stuff. Yep. Yeah.
How about the networking requirements of something like this? I think this needs quite a lot from the network between the different worker nodes and the control plane and so on. Is there any way to provision some VPN like WireGuard or some other mechanism to create necessary encrypted networks between these things?
Do you mean the Kamaji or the whole network?
Between mostly the worker nodes and then the control plane.
Yeah. So I think Kamaji offers some option to use connectivity, and I'm not sure if it already support encryption, but at least you can put some VPN and route it around. You don't need to have them in the same network.
So connectivity is a kind of VPN for Kubernetes API servers.
Yeah, that reminds me actually of KZOS and the fact that it's actually using connectivity, but I don't know have you compared this to Cosmotron? And how is it, in a sense, different? Just Cosmotron is, for those who might not know, is KZOS operator for multi-cluster deployment. It also has integration with Kapi, etc.
Yeah, I think I have investigated Cosmotron at some point, but I have never tried them on, so it's difficult to compare. But I only compare the size of the project, and I think Kamaji is a bit, how to say, yeah, at least Kamaji supports connectivity, but I don't see a similar option from Cosmotron. But of course, I'm just very noob on that. I have not checked it out.
Cosmotron is fairly new too, so I don't know.
Yeah, yeah.
I was simply wondering, honestly, I haven't tested.
Yeah. But yeah, I check out, but I just drop it because it's only support KZOS and we don't use it. Any other question? If not, then thank you very much for staying this late. And of course, it's my first time, so please forgive me if I bore you. Yeah.